Welcome to the first FRC Robotics Competition Java tutorial from FRC Robotics Canada. This video will take you on a tour of the FRC Java environment in Visual Studio, with a focus on the command robot environment, as that's what we'll be using for the rest of the series. If you haven't yet downloaded Java, the FRC Java plugins, Visual Studio, or the LabVIEW software, there's a link in the description box for instructions on how to do just that. All of the code made for this series will be posted, along with comments, on the FRC Robotics Canada GitHub, which is also in the description box. When you open Visual Studio, click on the Explorer, the top icon on the left sidebar. Press Ctrl, Shift, and P, or Command, Shift, and P on Mac, to open up a text field called the Command Palette, where you can then type wplib, create a new project. Select that option. Then, you'll be prompted to input the information needed to start your project up. In Select Project Type, choose Template. In Select a Language, choose Java. And in Select a Project Base, choose Command Robot. Command Robot is the environment that we will be using for this series, but Iterative Robot is a popular one used by many FRC teams, so I'll be briefly explaining Iterative Robot as well. To summarize Command Robot, it's an object-oriented environment where each command and each subsystem on your robot are their own classes which you can access in your main. From there, you can choose a project folder or create a new one. Then, enter your project name. Name it something relevant to keep things organized. I'm naming mine FRC Java Tutorials 2019 for that reason. Then enter your team number. Choose whether you'd like to open your project in a new window or the same one, and you're all set. Your project folder will appear in the Project Explorer, which is usually found on the left-hand side. Within that folder is the source, or SRC folder, and within that, there will be Robot, Commands, and Subsystems folders. In Robot, there are three classes: OI, Robot, and Robot Map. The operator interface, OI, class will contain your joystick and joystick button instances, as well as joystick button assignments and joystick accessors. You will use this class to assign commands, functions the robot executes, to your joysticks. Robot Map holds constants that you can access in other classes. Robot has the most going on, and it's the only file you'll find in your Iterative Robot's source folder. The Robot class is where everything is scheduled and executed. It's your main for the project. At the top are instances of the subsystems, commands, and other classes used in the robot project. There are different scheduling methods for robot, test, autonomous, and teleop. The robot scheduling methods run regardless of which match period you're in, while the others run during the respective periods. The initializing, or init, methods, for example, autonomous init, are called once at the beginning of each period. Robot init is called once the robot turns on. Autonomous init at the beginning of autonomous, and so on. The periodic methods, like teleop periodic, loop several times per second during the respective periods. So, teleop periodic executes several times in the teleoperated period. The second folder in the source folder is commands. Inside, you'll have an example command. Let's run through how commands execute when called. The first method is your constructor, where you can state subsystem dependencies and your constructor variables. Basically what that means is this is where you tell the command which subsystem you're referring to in your command and what parameters the command needs. The next method is initialize, which executes the code inside once at the beginning when the command is called. The execute method runs over and over again until the isFinished method below returns true. Once isFinished returns true, the command moves into the end method, which executes once before the program exits the command. Let's move on to the subsystems folder in the source folder. There is also an example subsystem already in there. The subsystem classes start off pretty empty, with only a default command. If you'd like to use a constructor, you would have to make it yourself. This class is also where you create instances of motors, pneumatics, and sensors, which you'll use in the methods that you create for your robot to run. Last thing before we wrap things up, how to deploy your code. When you're connected to the robot, you can deploy your code by going to the top right corner of your workspace, clicking on the ellipsis, and clicking Deploy Robot Code. And that's all. There's your intro to the FRC Java programming environment. Our next video is on making a simple drivetrain and drive command. See you then!